Hi everyone, and welcome to today's lesson. This is Getting Started Part 5, and yes, it is the last video of this unit, and it is also the last video of the course. There will be no more examples of natural deduction. Today's it. So, with that said, let's go ahead and get started here. We have some interesting problems that we will be doing in PD+, our derivation system for our language PL, and everything is fair game. So all the replacement rules, including one that I just showed you, quantifier negation. So everything's fair game here. So I'm actually moving a little bit ahead of the book. It's actually in section 10.3 where they introduce PD+, but I say we can feel free to use it now. So there it is. Everything is fair game at this point. So let's begin with 10.2e number 1b, and then we'll move through those problems as you see. Okay. So they give you the argument. You, by this point, know exactly what to do. You put the premises up on top. You put the conclusion there at the bottom. Now, when I looked at this for the first time, I actually didn't try to do what I ended up doing. Initially, I tried other things. As a general strategy, I always try to use a combination of non-subderivational rules to acquire my conclusion. And I tried a couple of things. Not for too long before I realized it wasn't going to work out, but I did try a couple of things. So in this case, if you want to try something before then, I want you to convince yourself that there's probably not another way to do this. Instead, what I decided to do is I see number 2 there, the existentially quantified sentence. And if I see an existentially quantified sentence in the premises, I sort of suspect that I'm going to have to use it. So that's sort of my thought process behind this. So I figured, okay, let's go ahead and do an assumption or a subderivation for existential elimination. Now, I've said that this is sort of one of the harder rules to use, but it is also one of the most powerful rules. I really do mean the second thing. It is a powerful rule. As you can see there at the bottom of the subderivation, I just put my conclusion in there because I know that if I can get there, I'm done. That's it. Let me say something about it being one of the harder rules. What I mean by this isn't that it's super complicated. It just means that there's more requirements than normal. There are 3 criteria that you have to meet when making this assumption. So it just requires a little more thought. That's all that I mean when I say it's one of the hardest rules to use. So what are the 3 criteria? Well, it has to do with the individual constant that we are using. In this case, line 3, it's A. So we have to make sure that it's not in 3 places. It can't be in the assumptions. So take a look at 1 and 2. I don't see A anywhere in there. Great. All right. It also can't be, second place, it also can't be in the existentially quantified sentence that you are using for your assumption. So I took line 3 from line 2, right? Line 3 is an instance of line 2. So I have to check that line 2 doesn't have a lowercase a. Now, we've already checked for that because, it's one of the premises, but sometimes the sentence that the existentially quantified sentence that you are using for your assumption, it isn't in the premises, so you do have to double check. So in any case, right now, I don't see an A in number 2, so we're still set. And last but not least, you have to check that your individual constant isn't in the target sentence. So as you can see there at the bottom, there is no lowercase a there, so we are good to go. This assumption is a legal assumption. Okay. Having done that, well, number 1 looks nice and ready for us to do a universal elimination. So I went ahead and did that. And notice that because I can replace the variables in number 1 with any individual constant, I went ahead and used an individual constant that would be very useful to me. I chose the lowercase a because, as you can see, that allows me some opportunities for line 5 via the use of line 3. So I'm going to go ahead and just take out the GA right now. I want you to notice it's a simple 3-4 biconditional elimination. So now that we have the GA, well, I know that GA is one of the predicates that I'm ultimately looking for down at the bottom of the subderivation. I'm looking for fx and gx. Looks like I have the GA right there. I actually also have the FA up there in line 3. So here's what I'm going to do. I'm going to go ahead and combine these right now. 3, 5, ampersand introduction or conjunction introduction. And now I have A is F and, so FA and GA. And at this point, I'm able to do the simple existential rule, existential introduction. So there it is. From line 6, we get line 7. That's the transition. And if you can see that, well, then we're done. As a matter of fact, now I have the justification here for line 8. It's to the existentially quantified sentence we began with, and the subderivation, which is lines 3 through 7, existential elimination. So that's how that one goes. And by the way, this is sort of the difficulty level that you are looking for in test 4, right? So that's, if you can do this, I think you'll be okay. All right, let's keep going here. Okay, so it looks like in this one we have a universally quantified sentence up in the premises. We also have an existentially quantified sentence there. And we have to work our way down to an existentially quantified sentence, GZ. So when looking at this, I can sort of tell that there is no real way to get there without using an existential elimination subderivation. This is because even though premise 1 does give us a lot to work with, it is, even after we remove the universal quantifier, it's still a conditional. So we would still need, the antecedent in some way, or maybe a negation of the consequent. But we actually have nothing available to us other than premise 2, which is existentially quantified. So if we wanted to use any of the material inside of that existentially quantified sentence, we would need to use existential elimination. So I already can kind of tell this requires existential elimination. Moreover, the property that is down at the conclusion, G, I can actually see that pretty clearly in premise 1, and it's a consequent of a conditional. So I know I'm going to have to dig that out. So we actually have to work our way down there. So I'm going to go ahead and just immediately assume this sentence, FA and DA, for existential elimination. This is because I'm free to do this. This is a legal move because that individual constant A, it does not appear in the premises. It does not appear in the target sentence there of the subderivation, as you can see. And it's certainly not in the existentially quantified sentence that we're pulling out, that we're creating an instance of, right? So it's not in premise 2. So that looks pretty clear to be a legal move. And as you can see in my subderivation, I set up the conclusion there at the bottom of the subderivation because, again, that is the power of existential elimination. If I can show that we can indeed get to existential Z, GZ through that assumption, that I can go ahead and end that subderivation and set that up on the main scope. So existential elimination, again, super powerful. Okay, now that we have this FA and DA to work with, well, I did select A as an individual constant. So I'm going to go ahead and, on the next move, I'm going to go ahead and do universal elimination from premise 1. And I'm going to select the individual constant A to be the replacement of those X's from premise 1. Of course, I hope you can see that that is immensely useful at this point. That is because I can pull out from premise 3 or line 3 the FA, that's a simple conjunction elimination, and then using 4 and 5 together, I can do a conditional elimination and pull out the GA and HA. So selecting the individual constant A at line 4 is instrumental. I mean, it is an essential move. You could have technically selected B or lowercase c or lowercase d, and you would have gotten nowhere, right? You need, whenever you are eliminating the universal quantifier, you definitely need an individual constant that will be useful at some point. Okay, so from here, it's pretty straightforward. We go ahead and take out the GA from line 6, conjunction elimination, and then simple enough, existential introduction. If Albert is going to, I don't know, Ireland, then someone is going to Ireland. There exists a Z such that Z is going to Ireland. So that existential rule, existential introduction, that one's the easy one to use. That's kind of the jargon that I use, or the language that I use. Anyways, we did arrive at line 8 through our assumption there, the subderivation, which means we can end the subderivation and justify line 9 with number 2, the existentially quantified sentence that we began with, and the subderivation 3 through 8 that begins with an instance of line 2. So that is how we justify line 9, and that is how this solution looks. Now we get to do some theorems. Theorems, let me assure you that they're not supposed to be scary. In a way, it's actually liberating, because you know you have to begin with a subderivation or rule, so it kind of cuts the possibilities in half, actually more than half. So here's what I always do. I look at the sentence, I find the main operator. Guess what? It happens to be the horseshoe in this case. This is a conditional. Excellent. If I know it's a conditional, my guess is I'm going to go ahead and use conditional introduction. It just seems pretty evident that there's not really any other obvious way to get there. So with a conditional introduction, you assume the antecedent, you try to work your way down to the consequent, and if you can do that, you can end the subderivation, and there is your conditional. So how can we get from line 1 down to existential quantifier Fy? How do we get there? Well, let's begin with the obvious move. Let's go ahead and take out that universal quantifier through universal elimination of line 1. And tell me if you can see what to do next. It's actually a lot easier than you might think. People want to make this more complicated than it needs to be. You already have Fa. That means individual constant A has its property F. So let's just say we know that, I don't know, Alice is flying currently. Great, that means we know someone is flying currently. So we can actually go from line 2 directly to line 3 right now. That is a simple existential introduction. And because we've arrived at the target sentence, we can end that subderivation. Line 4 is justified through lines 1 through 3, conditional introduction. Simple as that. Okay, one more. I believe this is D. And again, I see an introduction, a conditional here, which means I'm guessing conditional introduction is the way to go. Antecedent goes up on top as the assumption, and the consequent goes at the bottom of the subderivation. Now, at this point, there's actually quite a few ways you can do this. I mean, you can technically use another subderivation or rule at this point. One of the tilde rules. Some of you love them. Okay, cool, awesome. I'm going to do something that I like to do, and that's often the case that you have to do it this way. I work from the bottom, actually. So what I'm going to go ahead and do is, I know my target sentence there at the bottom of the subderivation is tilde universal quantifier fx. Well, as it is, that is a negation, right? Tilde is the main operator. Sometimes I find it easier to work just with universal quantifiers and existential quantifiers. It just kind of makes it easier for me because I'm so familiar with those rules. So even if you're not as familiar with them, sometimes you want to do a move like this. All I did here was applied quantifier negation. And I do this just to see if maybe there's an easier way to go about this. And once I can see the equivalent, its equivalent form as an existentially quantified sentence, maybe I see more opportunities. So that's what I did there. And once I've done that, I can actually see how this proof ends. It's already basically done. I want to make a point here, though, about quantifier negation. So as with all rules of replacement, quantifier negation can be applied to subformulas within a sentence as well as to an entire sentence. So I really suggest that you check out the section of the logic book 10.3 on quantifier negation, because they give you many examples so you can really kind of master this rule. It comes in extremely handy. It makes proofs substantially shorter in some cases. So make sure to check that out real quick. Also, I don't want you to commit a very kind of common mistake here. So here's what I'm going to go ahead and say. Be sure you are applying the tilde to, I should say, the entire portion that the quantifier applies to. For example, this is okay. Let's take a look at that sentence. It's the one that we were just working with, actually. So that is totally okay. Here is what's not okay. Notice that in the sentence on the left, when we move the tilde into the sentence, we actually only applied it to the antecedent of that conditional. But it doesn't work that way. You actually have to apply it to the entire grouped sentence. Basically, the existential quantifier, it applies to the entire sentence in parentheses to its right. So you have to make that tilde apply to that entire section in parentheses. It can't just be the fx. It has to be the whole thing. So this is bad. Don't do that. The way to really do it would be something like this. Notice that as you going from the left to the right, as you take that tilde and apply it to the portion, the sentence in parentheses on the right, it turns the universal quantifier into an existential quantifier, and then applies to the entire sentence in those grouping indicators, right? So you can't apply it to just a portion of it. It has to be the entire sentence. So I just want to make sure that's clear. Please, again, do check out section 10.3 for more on quantifier negation. But that's my basic warning here. Watch out when you're doing this. Otherwise, it'll make your proof wrong. And instead of shorter, it'll just make it, well, it'll definitely be shorter, but also wrong. So watch out. Okay, so back here. Tell me, maybe you should pause right now and see if you can finish this proof on your own. It's actually fairly simple. If you already have tilde fa, if you already know that Alice is not flying, well then you know someone is not flying. So you can actually go from line 1 down to line 2 there, existential quantifier tilde fx, as a simple existential introduction. Then we already know that between 2 and 3 it was quantifier negation. We just explained that. And of course, because we went from the antecedent to the consequent, we can end that subderivation, and we justify line 4 through lines 1 through 3, conditional introduction. That's how that goes. I'm hoping that by now you are understanding this language. It's becoming familiar to you. I bet you if you show your homework to people who haven't taken this class, it just looks like absolute gibberish. But this is what happens as you get more comfortable with formal languages. And there is a direct connection to other formal languages, such as, whether it be computer programming languages or even there's actually a connection to music theory, which we don't talk about in this class, but you know, there are many connections that you can see at this point, I hope. So I hope you're not completely miserable right now. You have a ton of practice to do. Please email me if you have any questions, and I'll talk to you soon, hopefully.